I don't think it didn't happen. I don't think you ever your number and stuff to get it. You don't. Yeah. Yeah.
Okay, wait for you guys to spend some time working through these problems on your own, the keys attached. But what I want to do is maybe have you guys start on this for maybe 5 or 10 minutes, and then I'll go back and kind of highlight some problems and walk through the steps for each of the problems. But I definitely want to see if you're able to, attempt these problems on your own, at least, trying to figure out what is the first step, right? That's always the hardest thing about any problem is just figure out what the first step is. If you figure out what the first step is, then everything kind of falls into place a little bit better. Okay, so let's start 5 minutes, see how far I can get, and then I will go through 1 through 4, talk through the steps, and then you guys will continue with the vacuum. Okay, and then the key is attached, so you can always kind of check your progress. All right, get started, and we'll touch base in 5 minutes. Thanks. Robert. So your question for 39, limit x approaches to pi over 2, the right side of pi over 2. Cosecant to me is harder to visualize, so I'm going to write it as sine, 1 over sine. And then if I think of that pi over 2, getting into that x, it'll be like pi, sine of pi. So if I want to visualize what sine of pi looks like, sine of pi, this is my sine graph. Sine of pi is 0, but if I'm approaching pi over 2 plus, or think about that pi from the other side of pi, it's coming from the negative side. So imagine a point that's getting close towards 0, like negative 0.0001. So 1 over negative 0.0001, that's going to be a very large number or in the negative direction. So that's why I think.
Thank you.
Thanks. Let me just go through 1 through 4, see if you guys have any questions. Remember that if we're evaluating a limit as x approaches the real number, that we're always testing to see what's happening at that. We don't want to just assume, oh, it's a factoring problem. I want to see that you are showing me that you're checking the right substitution, right? That you're confirming that you're getting 0 over 0 before you do all these other steps. Because if you evaluate your limit and if it gives you a real number, there's no need to do any of these factoring steps, right? If you get a real number, you stop, that's your answer. But sometimes we jump that first step and we assume that it's going to be a certain way. So if you do that, you're running the risk of getting the wrong answer because you're factoring and canceling out when, or you're stuck in a step here because you didn't realize that it's already a direct substitution problem. So number 1, we do get 0 over 0. That confirms that it's a whole. the strategy that we have to undo that radical is to multiply numerator and denominator by the conjugate. So once we do that, the numerator will show a variation of that denominator that we're looking for. We're looking for that x, right? That x is causing that denominator to be zero. So that's a good clue that you're looking for an x to pop up in that numerator region to get those x's to match and pair up and reduce. The rule of thumb is I want to see the limit notation until you replace all your x's with that value. Once you replace your x's with that value, then you're done. Then the limit can drop away and you're left with your answer. Okay. But if your variable is still in your expression, the limit statement still needs to be in front because you haven't yet replaced the value with x yet. Number two is straightforward here. 0 over 0, we know there's a hole in the graph, but the limit does exist. Factor, reduce, reevaluate. And my suggestion is that when you go through a limit problem, try to use arrows all the way through. Now, if you use equal sign on the test, I won't take off any points, but just to let you know, College Board is really finicky about that. So if you just use arrow and you never use equal sign until the very end, or not even at all, that's fine, right? The arrow is just an indication you're telling the grader, hey, I'm telling you what the next step is, but I'm not going to commit to these two being the same on the other side. So let me see. Yeah, it should just be a 1, right? You guys get a different answer? Do you guys say negative 1/4? Yeah, sorry. Okay, yeah. That's my mistake. I think I was thinking that these were opposite factors. Thanks. Yeah, thanks for correcting. But you guys confirmed that as well. You got negative 1/4 for number 2. Yeah. Thank you. Okay, I'll change that. Okay, thanks for that correction. Number 3, normally we would want to test 2, but the problem is we do get 0 over 0, but absolute value is a little bit strange. So we could write this out as piecewise functions and sketch the graph and visualize it. Or what I did was I just used 1.9 and convinced myself that at least from the left side of 2, I'm reaching a y value of -1. Typically, we want to go through our normal set of steps, but that absolute value kind of creates a bit of a exception. But I do want to, so that you guys can kind of get a fuller picture as to, this way works. That's a quick way, right? Just test 1.9. But if you want to visualize what's happening here, you can also do this, okay? Because we know this is true, right? Absolute value of x minus 2 is the same as an x minus 2 where x is to the right of 2, right? Because that's just an absolute value with the vertex at 2, or a negative x minus 2 where x is to the left of 2. Now that's just the numerator portion, right? That just breaks down that numerator absolute value of x minus 2. But to get a full picture here, if I just divide this by x minus 2, isn't that the same thing as what I have here? So if I do that to my original expression, I can also do it to my piecewise expression. And now look what happens here. This becomes x minus 2 over x minus 2 is 1. And negative parentheses x minus 2 over x minus 2 is -1. So what's really happening is this graph is just showing 2 different lines that are 2 horizontal lines, right? If you sketch this graph out here at 2, you have a graph that has a y value of 1 to the right of 2. And then you have a y value of -1 that is to the left of 2. And if you imagine, if you're able to sketch this graph out visually speaking from the left side of 2, I'm picking a point to the left side of 2, and by heading towards 2, you can see that my y value is holding steady at -1. So don't do all this work, but I think it's good if you can not only do it from one perspective, but you can also create a graph and have another way of confirming your answer. But just want to show you. Number 4, we have complex fraction here, but let's not assume anything here. Let's do direct substitution. We get 0 over 0. But we do need to, we know there's a hole. That hole is really from that x. The x is the culprit here. So I want to create a scenario where I can get an x to pop up in the numerator. But this requires me to go through complete a common denominator first. So common denominator, I'm going to force my two fractions to share a denominator of x plus 1. I do need to balance my second 1 to be a minus x plus 1 over x plus 1. Now I can merge my two fractions, clean up, bring that denominator up as the reciprocal, get the x to match up and pair up, reduce, and then reevaluate. That takes me to -1. All right, number 5, infinity. We have a different set of steps for infinity, right? Infinity, we compare degrees, but just be careful. Sometimes the degrees are not lined up in a standard form. So sometimes you have to go searching for your highest degrees. So my highest degree in the denominator does not show up until the middle term. And then I want to compare 5 with 5. I don't want to compare 5 with 2 because that's not my leading coefficient, right? So 5 and 5. My degrees are the same. I should take the ratio of the leading coefficients. Number 6 feels more complicated, but if I can get that 3 to the -x to go to the denominator, now I have a clean relationship here. My numerator is a polynomial. My denominator is an exponential. I'm approaching a positive infinity, so comparative growth rates works. My denominator is the faster moving function. So anytime my denominator is faster, I know my fraction is getting smaller towards 0. Number 7 and 8, we see one-sided limit, but we ignore the one-sided limits to begin with. We do direct substitution, we get 12 over 0. So now that I know that my graph has a vertical asymptote at that x value, I know I'm down to 2 options, right? I know that my limit does not exist, first off, but it's asking for a one-sided limit, and then I'm going to test a decimal on the appropriate side of that x value. Same thing for number 8. Test the decimal. Once I confirm it's a vertical asymptote. But what I want to make sure that we understand is that just because you see a one-sided limit doesn't mean that there is an asymptote and that you got to do decimals. So for instance, for number 1, I could totally just change my problem and do 0 from the right and -3 from the left, or vice versa, and my answer would not change, right? So this could be 0 from the left. If you get 0 over 0, just erase that one-sided limit. That one-sided limit has no bearing on your answer. You're still, whatever you get for your limit is going to be the answer for your one-sided limit. Okay, so don't automatically think, oh, decimals is one-sided limit. Only if you get something that tells you it's a vertical asymptote, right? So if you get 0 over 0, one side limit is not going to mean anything to you. Just think in terms of, okay, I'm just going to find my limit. I'm not going to let that one side limit throw me off. You're only playing with decimals if you are getting something that tells you it's a vertical asymptote with that 0 in the denominator and the non-zero up top. Okay, any questions? First page. Yeah. That's right. The limit technically does not exist, but that one side limit is rephrasing the problem as what is the graph headed towards from the left side of that x value. So whenever you see a one-sided limit, it may it's technically not asking for the full limit. It's only asking for the limit from that one side.
So if it's asking for the asymptote, it's always going to be one-sided.
Yes, and no, I think. So here's an example. Let's say I had an example that was this limit as x approaches 3 on the left side of 3 of 1 over x minus 3. Oh, sorry. Let me say, okay, so here, you know that this is vertical asymptote, right? But it's x approaching 3, so technically the limit doesn't exist. But then we may have to think about, wait, is there a subcategory that I can have? So then I would do a one-sided limit. I know I'm going to get asked, I know I'm going to get infinities here, but I just want to know, are these in agreement? If these are in agreement, I can put that to subcategory with my answer. If these are not in agreement, then I'll leave it as this time together. Number 9 is squeeze theorem. You can tell it's a squeeze theorem when you have 3 functions and they're asking you for the limit of the unknown middle function, but they give you enough information where you can find the limit of the outer functions. So the squeeze theorem, there's only 2 possibilities. Either it's conclusive and we can find the limit, or my outer functions are not moving towards the same y value. If that's the case, then we say our limit is inconclusive because squeeze theorem doesn't apply. And number 10, anytime I see continuity conditions or anytime I see piecewise functions with statement of continuity, I'm just going to go through continuity conditions, because if I can go through my continuity conditions, then my answer will just naturally show up for me just by virtue of going through it. So. So I take my reduced functions and I insert that name for each of these. Okay, if you have any individual questions, feel free to ask me, but I'm just going to let you guys work, go through problems and just kind of go back and forth. Um, That should be experience. Just score five, yeah, chance of them, they I'll make manage. Well, the best things actually do that the region has. Has raised to 1/2, so 1/2 of 6, 370. I did make a mistake there, so I did want to put that up. It's here, the base. And there's one that we I didn't. Well, it's not. Guys, thank you for catching the mistakes here. I took the square root too many times. It should be 4/5 and not 2/5 in my key. 4/5 and -4. What'd you do? I always just go to continuity. This is continuous, so anything that's continuous in terms of quantity condition. And then have negative just pop up once you get on. It's only surely that's yeah, right side of the space. That's not news. We didn't know about this, that's why it's only these are all separate. So the right one by for this time. If it was one rational function, then the truth was these are all these ones. Yeah. Yeah, I can't choose. Well, this is one of those exceptions where anytime you see a square root, you're going to get split asymptotes. And my reasoning is that if I were to insert, let's say, -100, my numerator will stay positive. So my denominator, it's going to turn into negative.
Okay,
So that's why I get a different
okay,
sign.
so for this one, you just doesn't.
Yeah, that's positive above, below. One will always stay positive, the other is gonna flip flop depending on the sign.
Okay.
It's a little zero, it's just. Oh, yeah. Yeah, you're right. I should have said Bergdorf is a.
Okay.
So I'll add that in. Yeah.
Um,
Yes, it would. So there's some points on. Yeah, we don't need it for this, but you should just ask in general. I think so. So this is. I'll just only pay versus. But I think he's not. I should have. You'll have to my perspective. Good and well, that's right. We're gonna have fun with it. My doors. This is true. We're trying to send you the photos of the school, you take back to me, back to the schedule. I'm just, yeah, I think the. Agents for microphones. The test is going to be. See if I can, Wait, so. So you gotta give them the paper. Oh, it's so dangerous. It's like, oh. Yeah, it goes. No, you don't make no, it's back. It's like. Paper cuts are nothing more. I said, I just don't know. No, you probably don't know.
Yeah.
You don't know what it's saying. You were probably zero, or something like that, this test. You put it, you know, there's this thing. I mean, it gets. Yeah, it's like just plug in, say. That's the real one. We're looking at all of them. We're going to go on stuff, maybe we see from all the graph. When it's, yeah, another thing, it's a few of these real, they do some very fast. Yeah.
Be about 3 pages, so a little bit shorter than this review sheet.
Towards the mirror meeting. Oh, I said, both of them just go. They're gonna go for the body. Well, it's gonna tomorrow, it's different. Guys, sometimes things this are weird, the output always fucking positive. And then when you're going to negative, the denominator will be negative. So probably sure that you're never finding. So square is all positive. The output. Has to be linked to it. Like it's got. Does this have to go?
It doesn't have to. It doesn't have to. Yeah, like. That's just.
So if you negative 4 combines, and like it doesn't exist. Yeah, so the next version is if that's which is negative. Okay. That's your additions. That's it. Yep.
It's literally lots of.
Or it's on class, that's the behavior.
Okay, everybody okay? First two pages? A couple of changes that I want to add to my key, make sure that also typos and as well. For number 20, I should have, it said identify type of each discontinuity. I should have named them. So vertical asymptote is a non-removable discontinuity, and then a hole is a removable discontinuity. I want to find the location of my hole. What I can do is obviously find the X value, whatever cancels out, and then plug in your X value into the reduced expression. Same thing as evaluating limit. So basically, if you were to evaluate the limit, that will also take you to the location of the hole as well. And then for 21, we know that there is a split asymptote because of the radical and the degrees matching. So I messed up here. Square root of 16 is just 4. I did square root of 4 is 2. So I took too many steps there. So for 21, the key is incorrect. It should show asymptotes at 4/5 and negative 4/5.
When you're looking negative, square root, like for number inside the square root become negative, and you can't take the square root.
Well, here's the thing is that you see negative infinity is in for x. X is a positive exponent. So that's going to turn into a positive value. So that's going to still remain safe. But that radical and that x to the even power will ensure that you're always getting a positive number. So that's going to allow for that denominator to all of a sudden change signs between two different directions. Yeah. Just being able to, okay, well, first that radical tells you there are two scenarios. So then I would like test 100 in both of these and convince yourself that the sign is either positive or negative. Oh, right. So
Or is there?
yeah, if it's principal values, meaning that if I just have square root of x to the 4th, that's always going to be a positive value. The only time I have to worry about plus or minus is if I have an equation to begin with. If it was an equation and I do this, then a plus or minus will show up. But if it's just an expression with no equal sign, it's always principal value, it's always positive.
So only if we do it to the expression. It's not already there. Only if it's not already there.
What do you mean?
If we're adding it to the expression, if we're reading the expression, the radical isn't already there.
Right. Yeah, if the radical is already there, then it's always positive.
Okay.
but if it's an equation and you take the square root, then the plus or minus shows up. I may do another one, if I can find another one, but I think this is gonna be the one. We're gonna finish this up tomorrow. Guys, you guys have, a little bit of, few problems from the AP practice. That's from the chapter 1 review, so I'll check that tomorrow. And we'll spend more time finish off this review. If I can find another review, I'll give that to you. But if not, then we'll just spend tomorrow continuing to review. And then Wednesday, we'll start our new unit, and then test is on Thursday. Give you an extra day to review. All right, come get your phones. No, I won't give you one like this. Oh, yeah. All right.